Everyone, I am Novelyn and I'm from Department of Medical Sciences and Engineering under the supervisor of Xu Haoren 老师. And for my master thesis, we'll be focusing in the in silico study on the activation mechanism of human beta defensin 3 bound to chemokine receptor CCR7 via the beta-arrestin dependent signaling pathway, especially in specifically in oral squamous cell carcinoma progressions. So before I go deeper for my research project, I would like to have an update for my course selections. So for IBGP scholarship, I still have one seminar left to take and 30 humanity courses and also arts of tea ceremony. However, for my own department, I still have one elective courses to take. So for the progress timeline of this semester, in the first month of September 2024, this year, I refine all of my research ideas, and next month, the October, I start to prepare the system simulations for protein-protein molecular docking and also the molecular dynamic simulations. And in the November, I start to do the extensions of the molecular dynamic simulations until the December is still also the extensions. And for estimations, all of the progress, all of the experiment done in the computational modeling will be finished by this December. So in the next semester, after the winter break, I will have the data analysis of all of my research data until the April of 2025, and May and June will be focusing on the thesis writing and thesis editing. So here is all of the system that I perform in the computational design. So I perform this experiment basically based on three different ligand, which is CCL21, CCL19, and also human beta defensin 3 bound to same receptor, which is CCR7. So here, first of all, I would like to do the molecular docking, and this progress is what I have done in my first semester of master degree, which is here my target is CCR7 bound to the ligand, which is the three different ligand to form a complex, and I would like to take this protein complex to do for a molecular dynamic simulations, and I would like to mimic the real environment of the human body by adding the POPC, which is the phospholipid bilayer, towards the receptor, because we know that the receptor is located in the membrane bilayer, and then also add some ions and waters to real mimicry. So why I will have a very huge interest to study about the human beta defensin 3, because from the previous research study have found that human beta defensin 3 actually has a multi-function antimicrobial peptide. It can perform as pro-tumor, or otherwise it can perform as anti-tumor peptide. So here, this paper have stated out that human beta defensin 3 can induce the SCC progressions, especially after bound to the CCR7 receptor. So, however, human beta defensin 3 is very unique, because when it bound to a different receptor, it will have a different effect. So if beta defensin 3 bound to the CXCR4, it will have an antagonist effect. But there is also some papers stated out that beta defensin 3, if bound to the CCR7, it will overexpress this activity and it will induce the agonist effect, especially in the SCC carcinoma. But a very interesting point is it is through the pathway or mediated by the NF-kappa B signaling pathway. So in this study, because previous findings have found that binding of beta defensin 3 to the CCR7 is mainly not rely on the G protein dependent signaling. So we would like to study whether the NF-kappa B activations has the correlations with the G protein independent signaling, which is through the beta arrestin. Why we have to understand about these correlations? Because we have the idea that after the ligand bound to the receptor, it has the capability to recruit beta arrestin, and the recruitment of beta arrestin will specifically activate NF-kappa B. So in this way, we have the hypothesis that we would like to study, which is the first one is we would like to study that does the human beta defensin 3, which is about the structure itself, what is the unique of this structure protein structure to perform as either agonist or antagonist in CCR7, this receptor. And the second one, we would like to study about the human beta defensin 3 induced CCR7 activations can result in distinct beta-arrestin recruitment, because not all ligand can induce beta-arrestin recruitment. So in this study, we would like to see whether beta defensin 3 can induce beta-arrestin recruitment compared to the CCL19 and CCL21, which is the endogenous ligand of CCR7. We would like to see what is the difference. And last but not least, if we can prove that there is a beta-arrestin recruitment, later on we would like to see that it probably has a plausible outcomes that also can activate NF-kappa B pathway. So in the next semester, I would like to do the analysis. However, right now, in this moment, I've already have some overview what is the receptor activation sign by looking at the molecular suites of the receptor, such as these four motifs that I would like to analyze later on. So here is the study, which is a very rough data analysis that I have already done. As what we can see after here I have already done until the 1.5 microsecond time simulations. We can see that actually human beta defensin 3 can induce activations. Especially we can see that there is open binding pocket in the allosteric site of this receptor. So further analysis will be done in the next semester. I think that's all for my presentation today. Thank you for everyone's attention.